how many of you know JavaScript? I think the better question would be how many of you don't know JavaScript at all or absolute beginner in JavaScript? Alright. So anyway, you'll get along. JavaScript, it's just non-magical thing anyway. So how many of you who use Vue have tried looking into how Vue works internally? Okay, one, two. Anyway, it's a great audience for me because otherwise I would be so done with my talks and everybody could have a break again. By the way, if you have taken this course on Front-End Masters or if you have gone through those two articles, you might want to just skip my talk because my talk is going to be pretty much about what they have written, but I'll take slightly different approach as to take you into the unknown territory using all the things that you have used, loved, or maybe hated so far about JavaScript. So, who am I? Well, I'm Praveen. I work at a company called VoiceSend. We are a voice tech machine learning startup and totally free from using the word AI. We work with Indic languages and voice where you have multiple people talking. So we are good with that stuff. If you need to know more, connect with me. I also am available on the internet with that handle. And I come from Hyderabad. So it's been a pretty good ride for me from morning coming here. Pretty much took as much as time it would have taken me in a train. So I do a lot of CSS work as well. The wallpaper that you see here, all these things that you see on the screen, all the stuff that I've done with CSS. So that's what I love a lot. Or probably stuff like this, where I created all these flags using single divs, no JavaScript for fun. So let's get back to reactivity, right? What is reactivity though? I keep talking, using this word again and again, but what is it? So say after I'm done with talk, all of you come to me and say like, this was the shittiest talk ever, right? My face is gonna be like that, right? And right after that, all of you punch me, I'm gonna be dead. Or in between, if Rahul comes in and gives me a lot of t-shirts for free, I'm gonna be this, right? So, I mean, not really, that's not gonna happen though. But if that happened, or all the things that has happened somehow made my face react. What has happened is my face has reacted to all the things that has happened, right? And this thing that my face has changed from one expression to other is called reactivity in a dumb way, right? But we don't punch screens or we don't do face things to understand our web technologies. We actually make things click on the screen and do dashboards. How many of you do dashboards? Some kind of dashboard or graphs and charts. Well, pretty much, right? That's our life. Yeah, so I'm going to take a more real world example, and in this example you can see that we click on the follow button, right? And something happens at the back end. The request comes in with a success, and then suddenly you see that things have changed, right? The thing to notice here is who made the text change from follow to following, right? Or how did the appearance of the button change, really? Do we understand that? Well, we wouldn't, because otherwise we wouldn't be having this talk. So let's go ahead. The thing is, when when you click that button on Twitter, something might have happened that changed the value of is following to true, right? They might have started initializing that variable to false, and then follow button text is computed based on is following, and then at later point of time, you just set it to is following, right? So the thing is that all these frameworks, right, be it React, Vue, or Angular, they allow us to build or update our UI from data model, right? And they also make our UIs react to data model changes. So you, for an example, in Twitter, when we set is following to true, the UI changed to reflect that, right? And they let us do all of this without touching the actual DOM, sort of. So for the most part, they don't let us touch it, or they say it's a bad thing to do, but you can still do it, right? So the thing is, how do they do it? right? And I asked the question, how do they do it? Because if you know JavaScript, it doesn't really work like that. So let's take an example to elaborate on what I'm saying. This example is pretty simple. We have number equals to 10, square is number multiplied by number, and you console logs. Amazing. Yeah. So pretty simple here. We are console logging square, and sure enough, we'll get 100, right? But at a later point of time, if we come back and say, well, number is now 20, the square is not going to be 400, right? That's what we want, but it's not going to be. It's still going to be 100, right? So what we are doing is we are trying to set the value of number to 20 at later point of time, and we want to see what the value of square is. It's not going to be 400 as we might expect. It's going to be 100, right? And for the same reason, if we go back and look at Twitter's code, changing is following to true when we are working with plain JavaScript is not going to work as expected. It's not going to change the UI, right? So all these frameworks or the framework that Twitter uses, how does it change based on what you have changed later on at some point in time? What we really want is a spreadsheet, right? In Avenue's way, if we see here, we have a column number, we have square. When we change a number, the value of the square gets re-evaluated again and again, and that's what we want. When we change the value of number, we want square to be updated, be it anywhere. So say if we were making something like this, right? Vue competitor, which is going to rock all the ways in JavaScript community and which also has a totally original logo, right? How would we solve this problem? Because without that, we are not going to make it to 100k stars, right? So the thing is, we don't have to look too far. We actually have been doing this whole reactive thingy from a long time. And drum rolls, here's your reactive thingy, add event listener. How many of you know about add event listener? Well, pretty good. So add event listener we have been using from the time of Big Bang, right? And if you have forgotten how it works by writing day in day out all your framework code, here's a refresher. So you have a document body add event listener. We are listening for a mouse move event on body, and then whenever that happens, we want to log our x and y coordinates, right? And if we run this code, we are going to see something like this in our console, right? In this case, the mouse was moving from top left to the bottom right diagonally. The thing is, if we go back and look at add event listener, how it works, we'll see three rough things, right? So the first thing is it stores the handler that we have passed somewhere. So we don't know where it stores, but it stores it somewhere. The next thing is that when we store it and then event, say for an example, when we are moving the mouse, something tells that handler that, well, this mouse has moved, you should probably do something now, right? And then the third thing is whenever that happens, it goes ahead and executes that handler. So and inside handler whatever we have written, that will get executed. So in previous case, we were executing console log, and that's what we saw on our console as output, right? So don't take my word for it. You can actually go on Chrome, put this, inspect the body, and you can actually go to event listener tab and see that it actually stores it somewhere against the event that we have said, oh well, this is the handler, right? I'm going to stay there for one more second so you can see it, right? So now my finicky brain starts to think, well, if we can do something similar to what add event listener does, but for variables or data properties, we can probably solve this problem of reactivity, right? So how do we go about it? We know how add event listener works, so let's start coding our solution, and then we'll start building on top of this solution that we are seeing, okay? We'll start refactoring and stuff like that. So first we start with handlers, which is going to be our storage, because we know that add event listener stores our handlers somewhere. We are going to initialize our variables, so these are our data that needs to be watched or changed. and we have current handler set to null. Now why is this the case, we will see at a later point of time in the presentation, but assume that this is going to hold our handler for now. Then there is a function called add property listener. So it's exactly the same thing what add event listener does, but it works in a slightly different way. And what it does is simply pushes the current handler into the handlers array, right? As simple as that. The next thing is notify handler. So when you move your mouse, something tells the browser that mouse has moved and you should probably trigger the handlers, right? In our case, we have to do that part manually. So that's why this function is there, which is going to just loop through all the handlers and execute them one by one, right? So this is all the setup work, and now comes the part where we do the actual code, or we actually watch for code changes. So the first thing is our handler. Now in our handler, all we are doing is recalculating the value of square and assigning it, right? So that's number multiplied by number, and then we say add property listener. So at this point of time, whatever is current handler is going to be stored in our handlers array, right? We just did that, we stored that handler in our storage. Next we execute current handler, so that's going to calculate the value of square for the first time, right? And at this point, if I console log square, it's going to give me 100, right? Are you all with me so far? Okay, so the next thing is what we want to change the value of number, right? So we change the value of number to 20, and like browser tells, well, mouse is moved, we say, well, this is the time we should notify the handlers, and we call that manually here using notify handlers. And sure enough, if we log console log square, now we get 400. So we are probably pretty much on the track, and the system somehow works, but there are still little bit of problems. So now let's go through the problems, okay? And before we go through the problems, let's look at what our goal is. Our goal is to do this. When we set the number to 10, we should get square exactly as 100, and when we change the value of number to 20, we should immediately get the value of square to be 400, right? So our code is not really doing that. There is a lot of manual work, and there are few problems that we can solve to get rid of all that manual work. So let's start describing what those problems are, right? So number one is we have to scale this solution. If you look at add event listener, right, we added a handler for mouse move, we could add another listener for click and all the other events, right? So similar way, we have to add a lot of handlers for our properties. What we just did right now is for just one property, and that's a lot of work. So we somehow need an abstraction that will allow us to reuse the same piece again and again for different properties, right? So that's about scaling. The next thing is we want to store the handlers automatically. When we say add event listener on click do this, we are really explicit about what we want to do when click happens, right? But in our case, when we are watching for data property changes, we want that part to happen automatically. So whenever a function uses a property, that function gets registered as a dependency, right? And the third part is notifying. Again, browser does the notifying part automatically, we don't have to do that. And right now we had to call notify handlers all by ourselves. So that part also is something that we need to solve, okay? So we start by looking at the scaling problem first, and to do that we will create this abstraction called dep. Alright, dep is just a class that does the dependency tracking, okay? And it's a very simple class. All it does that it takes our storage, takes the storing function and the notifying function in a class function, and I'll just go through, okay? We have constructor which initializes our store. Now it's not an array here, it's a set, because we don't want a handler to be added twice. So if it's a set, it's always going to be 1 no matter how many times you add it, okay? Then we have the depend, which is exactly the same as add property listener, but since it's a class that we are calling as a dependency thing, so we call it depend. And at this point we see whatever is current handler, we want to depend on it, we want to put it in our handlers list. And the third part is notify, which is the same as notify handlers, right? So what we have done here is we have taken the code that was there earlier and put it in a class, so we can now instantiate it, right? And we can create as many as instances we like and attach them to our properties. So that's scaling problem number one. The other thing is, okay, one thing is, when we have converted this whole part to a class that's called dep, we can now go back to our previous code and change it slight bit to make it cleaner. So what we have done is, I have just created a new instance of dep, and then instead of where we were calling add property listener, we are now calling dep.depend, which does the same thing. And where we were doing notify handlers, we are just calling dep.notify. It's the same code, just that the logic is now encapsulated in a class. Okay. Now here comes the problem number 2. If you look at this bit of code, right, where we are setting what the current handler is, and we do well, depend on that code now and then call the current handler. So initialization of the value and all that stuff, it's going to be repeated for every property, right? So what we do is we wrap this in a function, right, so that we can call this function again and again with the handler that we want. Now you can ask me why current handler is being set to null at the end, and I'm going to answer that at the very end of the talk, but that's what we do right now. So we create a function called watcher, which takes in our handler function as an argument, and then does the same thing that we did above. Well, we set it to current handler, we call the depend on it, we call the current handler, so the value is initialized, and then we set it to null. You can think of it that we are setting it to null for now so that other properties can use this. Okay. So we have taken care of two pieces here and made them reusable, but we haven't really reused them so far. We have made them reusable but haven't really used them that way. So what we need to do is, again, I said that we need to create instances of our dep class and then attach it to different properties. But how are we going to do that? Because you can't just attach things to variables, right? And to demonstrate why we need to do that, we have two examples here. So in our case, the first case, number, square is a computed value. So square is computed from number multiplied by number, and when we are storing dependencies for number, we want to store this function in the dependency store. But when we are looking at different property, like we add listeners for different events, we want to store it in its own storage, right? So that's why we need to create multiple instances of dep, so we can store multiple dependencies for their own properties. Okay. Now we also need to know when a property was actually touched, or whether it was set or get or accessed or modified, right? Why do we need to do that? Because that will give us an opportunity to create that dep class that we are talking about. When we create the class there and then say, well, now we call dep.depend, it automatically can register what are the current handler in its handlers list. So this is where object.define property comes in. We wanted a way where we can know when a property was accessed or modified, right? And if you look through ES, we find that object.define property allows us to hook into those I think lifecycle methods of a variable, where you can say, well, whenever data.a has been accessed, the getter has been called, and whenever data.a is being set or updated, this guy is called, right? So that's what happens, and it's a pretty simple API. All we are doing is defining a new property called a on data, and we are just hooking into whenever it is get or set, right? So now we have pretty much all the pieces that we need to make things reactive. Okay, so we take the first step in that direction by changing our variables to a data object in which we keep the variable as property. Okay, so number is now initialized as a property in data with the value as 10. The next thing that we do is make this number property reactive. Now how do we do that? So first we start with storing the initial value of number into a variable called internal value. Okay. Now why do we do that? Because whatever user provided as the first value, we don't want to lose it, because we might need it at a later point of time. We create a new instance of dep class so we can do our dependency tracking, and then we use object.define property as we have seen so far. So whenever the property is accessed, we call dep depend and then return the original value that we have, and then inside setter we set the internal value to whatever new value the user has provided, and then call notify. So now I want to go through this piece again, that whenever a property is accessed, we automatically do the dependency collection, and whenever a property is being set, we automatically do the notification part, right? So that's what we have solved so far. So we are pretty much there, but there is one thing missing. We could have a lot of different data properties, right? Right now I just made one property reactive. So how do we go about making all the properties in data object reactive? All we do, and remember this is our goal, which is why the setter thing that we did is now going to work, and I missed the slide there, so yeah, this comes up. And what we are going to do is we are going to create a converter, right? We are going to take the previous code that we have written for one property and just loop through all the keys in our data object. So this is the part where we are looping through each property in data object, and we are using exact same function to do the dependency tracking. Alright. So next, the thing is, we have pretty much solved our problem, but there are some mysteries left. So number one, we have scaled the solution, so we can now instantiate for every property, and also we can make all our properties reactive. Number two is we can store what is the dependency automatically now, because whenever a property is accessed, that happens. And the third is that whenever a property is set, the notification happens as well automatically. But how do we know which function to store? Well, if current handler is using A, then we need to store current handler in A's dependency tree, dependency list. And if B is getting used in current handler, then we need to store current handler in B's dependency list. So how do we even know which function to store? In case of browsers, we provide them with explicit function. Well, you go ahead and execute this function, so we know that this is the function that's going to execute. But in this case, we have to do some trickery, and that trickery is something that we have already done in terms of setting the current value at a top level, that is global level. And by using this thing, that JavaScript can only execute one function at a time, right? Whenever that function is executing, if we can somehow store which function that is, then we can use it anywhere, wherever we are doing dependency collection or the notification, right? So I'm going to go back to the dep class, and this is the dep class that we have written so far, and you'll see that that's what we do pretty much, that we said we only save current handler. And the way that this works is by making current handler a global variable. So we start with saying, well, current handler is null, and then whenever we pass a function that needs to be watched, we set that as current handler, and only after that do we call dep depend. So anytime any dep depend is called, we know that current handler is whatever function that is executing, that is using number variable or any other variable. And since we automatically do the dep depend part whenever a property is accessed or get, we can even get rid of the dep depend on line number 5, right? So this is the thing, since calling current handler is always going to execute this function which calls number, and numbers gets called again, and then dep depend is automatically done. And if we do all of these pieces right, we are pretty much there, right? So now we can set the number value to 10 and get the value of square as 100. We can set the value of 20 and get 400 as we would like, and we can all rejoice with our 100k star performing QJS. Right? By the way, the domain is available if somebody wants to buy. Maybe Rahul will buy it. Alright. So how do we tie all of this to our templates or things that get rendered? The thing is, a template is just an abstraction on top of a render function. If you write a template, that gets compiled into a function, and we already know how a function when watched can be all dependency collected, right? If we go back, our watcher takes a function, and that function could be anything. In case of rendering things, that's going to be our render function, right? So whenever things change, it automatically triggers render, and that's how our reactivity system works. And all the reactivity things that we have stolen from Vue.js to build this Queue.js can now be probably visualized in this diagram that we again stole from Vue.js documentation, right? I'm going to let this be there so you can see all the pieces that we have built and do they match here or not. Okay, so we have the data which is converted into setter getters using the converter function. We have the watcher which automatically triggers the render, and then the data knows when to notify or when to collect dependencies because of getters and setters and how we have set them. So we have built this thing which pretty much works, and which is how roughly Vue.js works, and including all the things that they have done to make sure the edge cases work as well. But there are some caveats to this, right? Not all things work in this reactivity system, and the caveats I want to just focus on three prime points. The number one is you must initialize reactive properties, right? Because whenever your component is initialized, the converter runs only once, and if you have missed that cycle, anything that you add to your component instance is not going to be reactive anymore, right? So due to this, you must see something like this, that there is a data function or a data property that returns an object, and anything that you want to be reactive, you declare it here by default. The next thing is again a continuation of the previous point, that if you can't make something reactive later on, then how do you add something later on which is going to be reactive? So for that, Vue provides us with a workaround with a global called vue.set, or if you are inside a component instance, you can do this $set and then say, well, on data I want to create another property called b which is going to have value 2 and it's also reactive. So you can do that. And the third thing is, which pretty much a lot of beginner will face, is that you cannot really work with array notation while adding things or removing things from arrays in Vue's reactivity system, because adding things like the first things how it is done in line number 1 does not trigger the setter or getter, okay, in our reactivity system. So what we can do is use the push method. Now Vue does a little bit of trickery there, where it wraps the push function to do change detection in its own way, or we can go immutable way, where we create a new array out of what we had earlier and then add the items where we need. So how do we get around all of these problems, right? And that's where proxies come in. Now I'm not going to talk about proxies here, because that's I think Rahul's job, and later on probably whenever he is presenting he'll talk about proxies. But proxies solve all of this problem, and the prime points that matter for me is number one, there is no need to use $set anymore, right? Because through proxies, whenever you add a property, they are always reactive. You don't need to go through the workaround. The array key notation works because again proxies are just way better than creating setter getters ourselves. And the thing is, now that we don't need to create setters and getters, because proxies can handle all of these things with one function instead of us creating so many different setters and getters for each property, the speed that you get is doubled, and the memory footprint is now half with proxies. And all of this you get without writing any extra code. You get the same thing under the hood with proxies API and using all the top level APIs exactly the same way that you used to use. So that's pretty much about my talk, and I hope I have given you a little bit of insight into how Vue's reactivity system works, or its caveats are. So you can, whenever you now use Vue, you'll probably keep those in mind. Praveen again, and yeah, thank you so much.